Today we are going to start the linked list and specifically the linear linked list. So in which we are going to start application problems, and on this we today I'm going to discuss you the polynomial representation with the help of linked list. Okay, so let's start. Okay, so if we talk about the polynomials, okay, so in mathematical, the polynomial is treated as like the combinations of two terms into a single, like ax square plus bx plus c. Okay, so for example, if we have any equations, like if I take 5x cube minus 3x square plus 9x minus 50. Okay, so this is called a polynomial. Now we can store this polynomial into a linked list. Okay, so how we can store this? So what we'll use, we will simply take each terms as a node. Okay, so for example, here the total number of terms is here, like this is one term. Okay, or we can say the first node. This is called the second node of linked list. This is called the third node, and this one is called the fourth node. Okay, so we will take the four nodes in a linked list to store this polynomial. Okay, so in each node we have two parts. Okay, so now in generally in any linked list we have two parts, but those parts is used to store two things. Okay, so the first part is used to store the info, or we can say the data, and the second part is used to store the address of next node. Okay, so here what we will do here, we will take three terms into a node. Okay, so which terms? So the first terms into any node is called the coefficient. Okay, so we can say simple coefficients. So that means the any number. Okay, like the any constant with their sign, like plus or minus. So the first thing we have to into the node, we will take the coefficient. In second, we will use the power term. Okay, so the second we will store the power. Okay, so for that, if we have to store these examples, this example into linked list, then we can use a simply terms. Let me erase these things. Okay, so that we can draw this into a linked list, and then we will start the code. Okay, so here I'm going to store this into a linked list. Okay, so the first node we have total 1 2 3 4 4 nodes. So this one will be stored the first node. Okay, now this is the second node, then the third node, and as well as the fourth. Okay, so we will take 4. Okay, so into the last node, as we know, it contains null value, so null is there. And into the first node, the coefficient is stored here, so the 5 is coefficient, and the power of x, so the power of x is 3, so we will store here. Now in second node, we have the value that is minus 3. Okay, so we will store here minus 3, and the power of x is 2. Okay, in third, we have the value 9, and the power of x is 1. And you can see into the last node, the value is minus 50. Okay, and the power of x is 0. So we will store here 0. Now, with the help of this, we can understand like how we can store this into a linked list. Okay, so these all are connected, and the first node we will store here the start. Okay, so we can treat it as at a start. So if we have to store these things into a linked list, then first we have to create the node, like how this data can be stored. Okay, so we will first create a structure so that contain the coefficient and power and the address part, so that the address part is linked with the another node, And the coefficient will be stored the value, the constant, and the power that will store the value of to the x. Okay. So this with the help of this diagram, we can understood like how we can store the polynomial with the help of linked list. Okay. So let's start the coding. So first what we have to do, so I'm going to create a new file that is called the polynomial.c. Okay. And here first we have to store the, okay, let me increase some font size here. Okay. So first we will take the header file. Sorry. As include stdio.h. Okay. Then we will create structure, and the structure we can simply call a node. So that will contain the coefficient COE we can take, and the second is power, and the third that will take the address. So we will create here struct node aspect next. So the next will store. Now we can simply redefine it this with the help of type def. So I'm doing here type def, and I redefine this as a node. Okay. So this is our structure. So that structure will store the any node, like any coefficient and power combinations of our polynomial. Okay. Now then after what we have to do, so first we will create like how we can create the linked list. So as we discussed in the earlier video, like how the nodes and the data parts will be stored. Okay. So for that, I'm going to define the main function here. Okay. And before main, I have to create three functions like void show that will show the linked list. Okay. Then the next add node. So that will take the two things like the coefficient and power, and then it will create it into the node. Okay. And this add node will take the address of linked list. So for that, I use here star. Okay. And it will also return after adding of that node, it will return the linked list, the final linked list. So that's I return it. Okay. Now the show will take any linked list, and that will display the complete polynomial. Okay. So here what we can do, so we will first call the add node, but before that we have to create a start node. Okay. So the start node I created here, that is named here start. Okay. And by default I put it into the null value. Okay. So if we are going to use the DMA, then we have to include malloc. Okay. And then we will store this like we will take the start equals to add node. Okay. And then I pass here start. Okay. So first it will take the address like the start node. This will add a node at last, and then it will return the x. Okay. So for that, I've taken here the two value, the coefficient and power, and then okay. So first we will take the two data from the user. So here we can write like enter coefficient. Okay. And we can store it in like with the help of scanning. So We can use percent %d, comma, and percent %COE. Okay. Then we will take the value, or we can take both at same time. Okay, so let me take both at same time, like coefficient and power separated with the space. Okay, and power. Okay, so here I'll take in the percent %d and POW. Okay. So these two will now create a node. So we will create a node like struct. So we do not require struct here. We will take node asterisk temp, or we can say the new node. Okay. So we will take a new node equals to node asterisk malloc size of node. Okay. So here we will create a node, and in this node we will store the value, the taken values from the user. So the coefficient will store the coefficient part, and the power will store the power. Okay. And we have another field here, that is next. So in next, we initially prepare null. Okay. So we have created a new node. Now we have to add this node into the start as a last. Okay, because we are going to consider like the each and every time whenever user enters any polynomials, so that will stored into the ascending orders. Like the highest power is first, then the lowest power, then the lowest power. So on that case, every time we have to add the new generated node at the last. Okay. So what we will do here. So first we have to traverse first. Like if the start is null, then we create the first node and return it here. Okay. If the start is not null, then we have to first traverse the node from first to last. Then we will add this newly generated node and then return the new node. Okay. So first I'll check here, like if the start is null here, like if the start is null, then I can simply return the new node. Okay, because the new generated node is our the start. Okay, so that's why we put null here. Okay, and if we add any node at last, then that node also contain the null value. So that's why these line number 23 is very important. Okay, so every node have the null value. Okay. So if this one is not true, in that case, what we will do here, so we will create a new temp node, and that will store the value of stars. And now we will traverse this temp until the temp of next not equals to null. Okay. So the last node, we will go to the last node, and here we try to move temp equals to temp of next. Okay. So whenever this node will move to the last node, then we will just add the temp of next equals to new node. Okay, and we will return this. Now we will return the. Okay, so what we will can return? We can return the start. Okay, so now this start will be returned. Okay, so now if we have to create the same instance, like I'm going to create a simple node here. Okay, like a simple polynomials. So for example, we are going to store here like the 4x square plus 9x minus 20. Okay, so we are going to store this. Okay, so for that, what we will do here, so we have to call this, that the total number of nodes is 3. Okay, so I'm going to call it 3 times. So let me copy the same contents here. Just let me copy this. So there is also shortcuts, but I don't know why it's not working. Okay, so the total 3 nodes is there. So that's why I added the 3 nodes, and now then I call the show. Okay, so that's we can see the start value. Okay, so simply we are going to we have added 3 nodes, and now we are going to show the polynomials. Okay, so for that we have to define the show. Okay, so the definition is blank here. So first, let me put a message. So polynomial is less than, okay, and then while start not equals to null, okay, and now we have 3 parts. Okay, so now let me discuss one more thing here. So whenever we have to print this value, okay, when we have to print this value, then we can clearly say here the symbols, the symbols of, like you can see here the minus symbol. Okay, so here is minus, this minus symbol, but here is plus. And if we talk about the first term, then this first term has the hidden plus symbol. Okay, so we have to also show the data with this sign symbol. Okay, so for example, if we have to print this, then in the first case we do not have to use, like for the first node we do not have to print this symbol. Okay, but after that every statements, every node must have their symbol either plus or minus. And if we talk about the minus symbol, then it will automatically print it. Like if we have a variable that is value the -5, so whenever you print this, then it will print -5. Okay, but same as if we have v equals to 10, like the positive 10, and whenever you print the value of b, then it will print 10 only. Okay, so the plus symbol is by default. Okay, so for that the first node, whenever we have to use first node, then the plus symbol is not mandatory. Okay, but whenever we talk about any node that started with the minus symbol, so the minus symbol will be printed. Okay, but after our first node, each node must have their symbols, like minus will be printed, but the plus symbol is not printed. So that's why we have to take care. We have to take care about, like whether the value is available or not, whether the plus symbol is available or not. Okay, so for that, first I'll print here the value of first node, like the printf. Okay, so %d, then x. Okay, x to the power. Okay, so that's why I put here %d, and now I'm going to use start of coefficient, comma, start of power. Okay, so the first value will be printed in, and now we move to the start, like start of next. Okay, so the first value will be printed with the help of this statements. And now for another task, we simply check whether the value is positive or negative. Okay, so if the start of coefficient is greater than 0, that means it is positive. So we have to print it with the plus value. Okay, so we will take here control V. Okay, and I'll put here space plus. Okay, so it will use plus symbol here to print this. But if the value is less than 0, in that case we do not have to use anything. Okay, and at finally we will use here like start equals to start of next. Okay, so we simply use space here. So each terms have some space, okay, associated space, so that we can differentiate the each terms. Okay, and sometimes we can also say, like if we talk about the last term like -20, then we have to put the -20 x is to power 0. Okay, so if you want to omit that, then that is also possible. Like what we can do here, we can say simply if the start of power equal to 0. Okay. So in that case, it will print only the value of coefficient. Okay. So I'll print here only the value of coefficient, not the power. Okay. So I just print it. So we do not require the value of power here. Okay. So that can be also possible. And here we will use the else. Okay. So we can use here the else part. So whenever the value of start is the value of power is 0, then it will print only one value. Okay. And we have also some options like we have to print it with symbol like -20 +20. Okay. So let me omit that. First, we have to execute this code. Like it's too complicated in that case, like too buggy, we can say. So I'm going to just print this simple first, then we will start the another version of the program. Okay. So now I'm going to start this code. So let me execute. So let me erase the all symbols here, like 4x square plus 9x minus 20. So we have 4 terms here. Okay, so it's giving the error in my log. So I'm going to use std leave here. Std leave. Okay, so now we can see, you can see the value here, the enter the coefficient and power. So first we will start 9 to the 9x square. Then I'm using -5 1. Okay, and then -20. Okay, so okay, I have to take 4 terms. I think I've called in how much times? I called it 3 times. Okay, so the 22 is there. Okay, so we supposed to print out like 9x square minus 5x minus 20 here. Okay. So -20 to 0, the power of in the last value is 0. So the polynomial is here 9x square minus 5x minus 20 to the power 0. Okay. So we have this, we have printed successfully in a polynomial. Okay. You can see here. Okay. And there is some this like this for this case, what we can use here, we will use simply a new line after the termination of while. Okay. So that's we do not require, and we can clearly see the output here. Okay. So we do not use the 0 terms here. And like the 0 is not here. We will print with the x to the power 0 also. Okay. So now I'm going to start again. Okay. So now in that case, I have uses 5 to the power 5x to the power 3, 2x to the power 2 or 1, and 9, 0. Okay. So in this case, it prints 5x cube plus 2x1 plus 9x to the power 0. Okay. So we can use this as the begin of the linked list application programs. Okay. So if we talk about the another versions, then what we can do here, we can simply use another version like the loop will goes up to start of next. Okay. So when the start of next not equals to null, so that the last node is not printed. Okay. Then we will simply use here like the value of starts, like we generally consider that at last term we do not have the value of x. Okay. This is the one version, and so you can freely print the value of the last term without x is to power 0. Okay. But in second syntax, what I like most, like I do not change this, like I just execute like the start not equals to 0. Okay. And then we will simply use here if the value of start of power equals to 0. Okay. Then this will be possible, like this. Okay. And then I use the same these things here, copy and else, and I put here control. Okay. So what does it mean? So if the value of power is 0, in that case we do not require x is to power 0. So that's why I do not use it, and I do not use here also. And for the negative symbol also, that it may possible the last term is in the negative parts. So we remove this, and for all the other cases it will execute. So this will execute only for the last statement, like the if the value of x is to power 0. Okay. And then all the other sections it will execute like this, like the value of power is not equal to 0. Okay. So now if we save this and we will execute this statement here, then you can see the difference, like I'm using the same output like 9 2 minus 5 1 and 22. You can see here 9 2 minus 5 1 and 9 0. Okay. So you can clearly see 9x squared minus 5x to the power 1 plus 9. Okay. So the value of 9 is positive. Okay. But if we see minus 22 versions, then we can also say I'm going to execute one more time. And here I am writing the 4 3 minus 4 2. Okay. And then minus 20 0. Okay. So here you can see 4x cube. I think x is here. Okay, sorry. This x should not be here. I removed the from first one, but second the x is missing. So you can see the 4x cube minus 4x square minus 20 is there. Okay. So if you remove this x, then the output will change. Okay. So just one more time, I'll execute it. So I have entered the same data 4 3 minus 4 2 and 20 minus 20 and 0. Okay. So you can see here the 4x cube minus 2x square minus 20. Okay. So that will be used like how we can store the polynomial with the help of linked list. And the main thing is like what the version of show. If you see the internet or the other videos, so the version of show will change drastically somewhere. Okay. But you can simply understand the logic, like how we can store the nodes, how we can retrieve the data, and at last you can see the details. Okay. So Okay, so this one is the demonstrations of the polynomial representation with the help of linked list. So you can continue for our next video. So that in the next video, I'm going to start the additions of polynomials. And thank you very much.